All right, let's dive into something huge. We're talking about one of the biggest shifts in science right now, how AI is completely changing the game when it comes to finding new planets, and maybe, just maybe, the first hints of life out there in the universe.
It's the one question that just hangs over everything, right? The one that has kept us looking up at the sky forever. It's what all our biggest telescopes and wildest space missions are really about. And now, for the very first time, we might actually have a tool that can get us close to an answer.
So get this. Right now, we've confirmed the existence of, well, a lot of planets outside our little solar system. We call them exoplanets, and the count is already over 5,600. So one thing is crystal clear. The universe is absolutely packed with other worlds. But, and this is a big but, just finding them, that's really just the beginning of the story.
Yeah, because most of those planets we've found are, huge gas giants or these scorching hot rocks that are nothing like home. The ones we're really after, the ones you and I are thinking about, those small, rocky, potentially Earth-like worlds, they are so hard to find. It's not just a needle in a haystack. It's like a single jewel lost in a cosmic rock slide.
Okay, so let's get into it. Why is this so ridiculously difficult, and why are human astronomers, as brilliant as they are, just not enough to crack this problem on their own?
So, to really understand the challenge, picture this. When a planet like Earth crosses in front of its star from our point of view, the starlight dips, but just a tiny bit. We're talking a dip of about 100 parts per million. That's like trying to spot a flea crawling across a giant searchlight from miles away. And to make it worse, that star isn't a steady light bulb. It's constantly flickering, flaring up, creating all this noise that just completely swamps that tiny planet's signal. For a human to try and pick that out reliably from all that chaos, almost impossible.
I love this quote from NASA's Andrew Vandenberg because it just nails the problem. It's like sifting through rocks to find jewels. If you have a finer sieve, you're going to catch more jewels. For decades, astronomers knew those Earth-like jewels had to be out there, but their tools, well, their sieve just wasn't fine enough. They needed a better way to filter through all that data.
And guess what that finer sieve turned out to be? You got it. Artificial intelligence. So let's look at how a team of scientists basically built and trained a cosmic detective that could finally see the things our own eyes kept missing.
So how do you teach an AI to find a planet? Well, it was a team-up between NASA and Google, and their approach was pretty brilliant. They took a neural network, which is basically a type of AI that's great at learning patterns, and they showed it thousands of examples. They fed it 15,000 signals from the Kepler mission that they already knew were planets. It was like a training program. The AI just kept studying them until it learned that perfect telltale signature of a planet crossing its star. And it got good, really good. We're talking 96% accuracy. So once it was trained, they set it loose on a whole new data set, all the weak signals that humans had looked at and basically given up on.
And you know what? It didn't take long at all for this AI detective to make a discovery that was frankly amazing. It found something that literally rewrote the astronomy record books.
Okay, check this out. The AI was sifting through data from a star system called Kepler-90, which is about 2,500 light-years away. And in that data, it found a signal that humans had completely overlooked. It was a whole new planet, Kepler-90I. And here's the kicker. It was the 8th planet in that system. That made the Kepler-90 system the very first one we'd ever found that has the same number of planets as our own solar system. Now, don't pack your bags just yet. Kepler-90I is about 30% bigger than Earth, and its surface is a blistering 800 degrees Fahrenheit, hot enough to melt lead. But that wasn't the point. The point was the AI had found a world that was totally hidden from us. It was proof that this technology worked. But here's the thing. Finding planets, that's just the beginning. AI is turning into this incredible cosmic problem solver for astronomers, tackling issues that just a few years back would have been completely impossible to fix.
I mean, just listen to the story. The James Webb Space Telescope, our $10 billion eye on the universe, had this tiny flaw in one of its detectors. A little electronic glitch that was making some of its images blurry. Now, you can't just send a repair crew out there, right? So instead, a team of students developed an AI tool called Amigo. This program learned the exact pattern of the blur and was able to digitally correct the images from Earth. It's incredible. They basically fixed a multi-billion-dollar space telescope with a piece of software, all from their lab.
So, it's not just about fixing our latest tech. AI is also letting us look back in time to decode the ancient history of other planets. This quote from researcher Eric Franklin really gets at the heart of it. He says AI lets us infer what the wind was like in the past, and even predict how a planet's surface will change just from looking at images.
And we're seeing this happen right now on Mars.
Scientists are feeding AI super high-res photos of the Martian sand dunes. The AI then runs simulations, figuring out how those dunes must have formed and changed over eons. And from that, it's actually reconstructing the climate history of Mars. It's telling us about winds that haven't blown for millions of years. It's pretty much planetary archaeology, but instead of a brush and a pickaxe, the tool is a powerful algorithm.
Okay, so let's recap. AI can find planets we can't see. It can fix our most advanced telescopes from millions of miles away. It can even read the history of ancient alien weather. That's all amazing. But it all leads back to the one huge question we started with. Can it help us find life?
Well, the first step is to know where to look, right? We need to find planets that could even support life in the first place. And for that, scientists have come up with this really cool new idea called a habitability signature. The thinking goes like this. A big liquid water ocean, the #1 ingredient for life as we know it, is really good at absorbing carbon dioxide out of the air. So if we're looking at a solar system and we spot one rocky planet that has way less CO2 in its atmosphere than its neighbors, that's a huge clue. It could mean it has a massive ocean sucking all that CO2 up.
But finding a world with an ocean, that's still just finding the stage for life, not the actors. So the real question is, can AI take that next leap? Can it detect the chemical fingerprints of life itself? And yeah, this is where it gets really, really cool.
Let me just throw a number at you. 90%. Just let that sink in for a second. 90%. That's the accuracy of a brand new AI that was built to do exactly that. But what is it actually looking for? How does it see life? Okay, so it turns out that life, chemically speaking, is really unique. It arranges molecules into super complex patterns that you just don't find in regular non-living chemistry. So scientists did what they did with the planets. They trained an AI, showing it tons of examples of biological and non-biological stuff. The AI learned to spot these incredibly subtle chemical signatures of life. It can now look at the molecular data from a sample, whether it's an ancient fossil, a bone, or a piece of rock, and tell you with 90% certainty whether it was once part of a living thing. And the most incredible part, this isn't some future tech. This algorithm is ready to go, right now, and they're planning to use it on the rock samples our rovers have already collected on Mars.
So that really brings us to what's next. Because with these kinds of tools now in our toolkit, the speed of discovery is about to hit the accelerator in a way we've never seen before. So what does the future look like? Well, right now, that life-detecting AI is being prepped to analyze those Martian rock samples. That's happening. Then, in 2026, the European Space Agency is launching a mission called Plato. Its job? To scan 1 million stars, with AI doing the heavy lifting to find any Earth-like worlds. And if you look even further down the road, the vision is for swarms of small, smart, AI-driven satellites that explore space together, making decisions on their own. It's a whole new era of exploration.
We started this journey with an AI that learned how to spot planets that were completely invisible to human eyes. Now we have an AI that's on the verge of spotting the chemical traces of life itself. It's been a wild ride. And it leaves us with this one final, kind of mind-blowing thought. After all these thousands of years of humanity staring up at the stars and wondering, could it really be an artificial intelligence that's the first to tell us that we're not alone?